Hi. In this video, we're going to talk about the price value of a basis point, which is sometimes called the dollar value of an O1. They mean the exact same thing. With duration and modified duration, what we are looking at is the percentage change in the value of a bond, in the price of a bond, due to a 1% change in interest rates. Okay, so that was the percentage change in the price of the bond. With price value of a basis point, we're taking a look at what is the dollar change in the price of a bond due to a 1 basis point change in interest rates. Okay, so duration is telling you percentage wise what is the change in the price of a bond. Price value of a basis point is telling you in dollars what is dollars and cents, what is the change in the price of the bond. So they're really measuring the same thing. What is the sensitivity of the price of the bond to changes in interest rates? Duration tells you in percentages, and price value of a basis point tells you in dollars. Duration is used more commonly, more frequently. And in this course, we will more often than not, or definitely more often than not, be referring to duration as our measure of interest rate risk. But price value of a basis point is something you should certainly be familiar with as a measure of interest rate risk. It's just telling you the same information, but in dollars and cents. So let me bring up the class notes for this so we can be able to kind of walk our way through this, because it's kind of a daunting formula that we've got here. Okay, so we start out with something that we're going to call delta P. Okay, delta P is not price value of a basis point. We'll get to that in a little bit, but we'll just call it delta P for right now. Okay, that is this formula right here. Okay, that is, like I said, it looks like it's a rather daunting formula. It's equal to 1 over 100 times c over y squared times 1 minus 1 over 1 plus y over 2 raised to the n power, okay, plus n times 100 minus c over y divided by 2 times 1 plus y over 2 raised to the n plus 1. Okay, good news for you. I'm not going to ask you to memorize that formula, but it's really not all that difficult. Okay, there are 3 variables in this formula: C, N, and Y. Now, you'll notice we've got right here is that C is the dollar amount of coupon payments made in a year. N is the number of coupon payments made, not the number of years, but it's the number of coupon payments that are remaining. And Y is the bond equivalent yield, or yield to maturity, expressed as a decimal. And this is based upon a par value of 100. Now, if you remember, we said there were 3 things that affects a bond's price sensitivity to changes in interest rates. That was how long it is until the bond matures. Well, that's right here with N, the number of coupon payments that are remaining. We said it was also the coupon rate had an effect. Well, that's going to be right here, the dollar amount of the coupon payments made in a year. And finally, we said also the yield on the bond impacted its interest rate risk. That's right here. The bond equivalent yield is a decimal. So the 3 things that will affect a bond's sensitivity to changes in interest rates are the 3 variables that we find in this formula. So let's go through an example, and it would be worth your while to try to actually plug these numbers into the equation and solve it and make sure you get the same answer that I did with it. Okay, so let's suppose we have a 40-year bond. It's got a 10% coupon rate and a 9% yield. Well, for that particular example, C is going to be 10. That's the dollar amount of coupon payments made in a year, okay? Because it's based upon a par value of 100, 10% coupon rate. So the dollar amount of coupon payments made in a year, 10% of 100 is 10. N is 80, because N is the number of coupon payments remaining. And it's a 40-year bond, so semi-annual coupon payments. There's going to be 80 coupon payments remaining. And Y is going to be 0.09. The yield is 9%, and Y is the bond equivalent yield, or yield to maturity, as a decimal. So it's 0.09. So if you plug in 10, 80, and 0.09 into this formula that we've got up here, okay, what you're going to end up getting is that delta Y is going to be, delta P is going to be $11.86. Okay, so what you also have to plug in is going to be what is the change in interest rates, okay? And so that's what this is. For a price change of 1% in interest rates or 1% change in the yield, delta P is going to be $11.86. So try that on your own. Okay, take these numbers right there, plug them into this equation, and see if you don't get $11.86. Okay, so what does that tell us at $11.86? That says on a $100 bond, if there is a 1% change in interest rates or 1% change in the yield, the price of the bond will change by $11.86. If interest rates go up by 1%, the price of the bond goes down by $11.86. If interest rates go down by 1%, the price of the bond goes up by $11.86. But we're interested in the price value of a basis point, okay? 1% change is a big change, okay? Is a big change in terms of interest rates there, okay? What we're interested in is what is the price going to change when there's just a 1 basis point change. Remember, a basis point is 1/100%. So the price value of a basis point is going to be delta P divided by 100. So this number we got there for delta P, $11.86, we divide it by 100, and that gives us 11.86 cents. Instead of $11.86, we've got 11.86 cents. So that tells us that if interest rates go up by 1%, then the price of the bond goes down by 11.86 cents. If interest rates go down by 1%, the price of the bond goes up by excuse me, I was wrong there. If interest rates go up by 1 basis point, the price of the bond goes down by 11.86 cents. If interest rates go down by 1 basis point, the price of the bond goes up by 11.86 cents. They say 11.86 cents. What does that mean? Well, remember, this is for a par value of 100. A $100 bond is going to move in price by $11.86. Now, I want to mention here, just like with duration, modified duration, this is not an exact number. This is an approximation. In fact, it really works very much like the way that modified duration does. You're taking the slope of the tangent line, and except you're using it to express not a percentage change in the price of the bond, but an approximate dollar change in the price of the bond. So for small changes, this is a pretty good approximation. For bigger changes, it's going to be off by a little bit. Okay, so here we are, our price value of a basis point for this bond. Price value of a basis point ends up being 11.86 cents. I'm going to introduce one more concept to you here, and that is going to be the price value of a basis point in dollars per million, because this is typically used by people who professionally manage bond portfolios, and bond portfolios are often in the millions of dollars. What they're interested in is not how much the price will change for a bond that has a value, a face value of $100, but how about a bond that has a face value of $1 million? That's much more frequent. So what we're going to do now is we're going to take this delta P that we calculated up above, that was $11.86, and we're going to multiply by 100. So you take the $11.86 delta P times 100, and that will give us our price value of basis points in dollars per million. So now what this is telling us, for a $1 million bond, face value of the bond is $1 million, if interest rates go up by 1 basis point, the price of that bond is going to go down by approximately $1,186. If interest rates go down by 1 basis point, the value of the bond is going to go up by approximately $1,186. So we've got 3 different concepts here. Okay, we started out with delta P. Delta P is based upon a 1% change in interest rates and a $100 face value bond. Then we went to price value of a basis point. It's still a $100 face value bond, but it's now a 1/100th or 1 basis point change in interest rate. 1/100th of a percent is 1 basis point. Then we went to price value of basis point in dollars per million, which is going to be, again, a 1 basis point change in interest rates, but it is how much the price of the bond is going to change if it has $1 million face value there. Okay, so we've got them all expressed here in this little paragraph on remembering. Well, what do we do when we've got a portfolio of bonds? Okay, because typically we're not looking to measure this for just one bond, although sometimes we might, but if we have a whole portfolio of bonds. Well, the more bonds we have, the more total value that they have, the more their price will change when there is a change in interest rates. Now, this is going to be different from duration. Duration was kind of an average of all the bonds because it was a percentage, okay? But because this is dollars and cents, a bigger portfolio is going to mean a bigger dollar change. It's not an average of them. It's going to be more summing them all up. So this is our formula here, okay? The price value of a basis point for a portfolio is going to be summing up the following, okay? First, N sub I, which is going to be the face value of security I. So in other words, we sum up, well, we're going to take the face value of each security, and we're going to multiply that by the price value of a basis point for that security divided by 100. So why are we doing this? Well, let's think about it. Price value of a basis point for security is how much that security will go up or down by when there's a change in interest rates. It goes up if interest rates go down, it goes down if interest rates go up, for a $100 face value. When we divide by 100 here, in other words, just this portion of it, price value of a basis point divided by 100, it's now not for a $100 security, it's for a $1 face value security. So now we've got a bond, okay, price value of a basis point is going to be for a $100 face value. Dividing that by 100, it's for a $1 face value. And they say, $1 face value, no bonds have a $1 face value. That's true. That's why we are then multiplying that by N, where N is the face value of the bond. So this is now going to give us, for each bond, what is its price going to change by for a $1? I'm sorry. What is the price? What is the bond's price going to change by for a 1 basis point change in interest rates? And then, of course, we sum that all up for our entire portfolio. So let me make sure we're clear here. This portion right here, there you go. That portion is going to tell us for a bond, how much is its price going to change, approximately. Pretty good approximation for small changes, but how much is its price going to change when there is a 1 basis point change in interest rates? Then when we take this here, that is going to be for a bond. Let me go back again, because I think I may have said that wrong. This portion right here is going to be what is the price of that bond going to change by if it has a $1 face value when there is a 1 basis point change in interest rates. Then this is going to tell us what is the price that bond going to change by when there's a 1 basis point change based upon the actual face value. Okay, so for this bond with its actual face value, what is its price going to change by when there is a 1 basis point change in interest rates? And then, of course, we are summing that up for our entire portfolio of bonds, and that'll tell us for our entire portfolio how much the portfolio will go up or down by when there is a 1 basis point change in interest rates. Okay, so price value of a basis point is going to be the price change for a bond with a par value of 100. Price value of basis points in dollars per million is going to be the price change for a bond with a par value of $1 million when there's a 1 basis point change in the yield. And then this right here is going to tell us for that actual bond that we have, whatever its face value is, because N is going to be the face value of the bond, what is its price going to change by when there's a 1 basis point change in interest rates? And then if we sum them all up, we've got the price value of a basis point for the portfolio. What will the portfolio bonds, what will its price change by in dollars and cents when there is a 1 basis point change in interest rates? Again, don't forget that if interest rates go down, that price is going to be going up. If interest rates go up, that price is going to be going down, and that this is not an exact number. It is an approximation. It's going to be about as accurate as modified duration is. Okay, so the amount that modified duration tends to be off, which we spent some time going over earlier, that's about how much price value of a basis point is going to be off there. So that tells us a little bit about price value of a basis point, also known as dollar value of an O1, which is measuring interest rate risk in terms of dollars and cents, as opposed to duration and modified duration, which measure it in terms of percentages.